Hello students, welcome to Showed Up Sir classes. This is Himadri Datta, and so in today's discussion we will be continuing with game theory. So first of all, in game theory, there are two players usually, player 1 and player 2. So there are two players, player 1 and player 2. So they have their option strategies which they can opt, which will give them some certain level of payoff. Now today, in today's discussion, we will be talking about Nash equilibrium. So today we will be talking about the concept of Nash equilibrium. So in today's discussion, we will be talking about Nash equilibriums. Now, there can be, in a game, there can be multiple Nash equilibriums, there can be two Nash equilibriums, there can be one Nash equilibriums. Now, how many Nash equilibriums there can be, it depends on the very game itself. So, first of all, I would like to define what Nash equilibrium is. Nash equilibrium is a strategy from where no player has incentive to deviate, or say Nash equilibrium is a strategy from where a player has no incentive to deviate given the other player's choice. So Nash equilibrium is, suppose for an example, say there is no like government policies or there is no police in the city. Now the people or agents, those who live in the city, they are governing themselves, so they do not need any external support or external vigilance, say. So when people have this self-correcting behavior, that is, they will not deviate from what the option, the best strategy is, we usually call it Nash equilibrium. So in economics, Nash equilibrium basically comes with like two player strategies. So we would write down like four, in today's class we write down four matrices, and we'll see how Nash equilibriums are there in four matrices. So first we'll start with this matrix. So first we'll write down a matrix where player 1 and player 2. Okay, so player 1 and player 2. So I'll write down U and D. This is up, down, and this is L and right. This is left and right. So I'll write down the matrix here. So here I'll write down E7. Here I'll write down 4, 6. Here I'll write down 6, 5. Here I'll write down 7, 8. So this is the matrix given, game theory problem given. Suppose in a question it is given, this is the game theory problem. Now first I'll explain what is this. These are nothing but the payoffs that the player gets. So these are nothing but the payoffs, and these are the strategies that player 1 or player 2 can opt. Suppose for an example, if player 1 opts this strategy, which is L1, now player 2 can either choose U and D. So given one player strategy, the other player can choose either of these two strategies. And here also, given player 1 strategy, say player 1 chooses R, player 2 can choose either U or D. So here, what is the case here? That is, for player 1, this is the optimal strategy. For player 2, this way we can find the Nash equilibrium. Now say, how do we solve Nash equilibrium problem? So in order to do Nash equilibrium problem, what we have to do is first say, for player 1, or say this I'll write as player 2, say it will be better. Now in this case, player 2 can either choose L or R. Now let's say initially player 2 chooses L. So when player 2 chooses L, like player 1 can either choose U or D. So in this case, when player 2 plays the first game, Then player 2 decides his strategy. We'll consider these two areas. We'll consider, take the first column, that is 8 and 6, and we'll compare between them. Now which one gives the most utility or more utility among these two? Obviously it is 8. So we'll conclude for when player 2 plays L, when player 2 plays L, player 1 plays U. So when player 2 plays L, player 1 plays U. Now similarly we can do it for R as well. So if you do it for R as well, see, if player 2 plays R first, now as we have said, when player 2 plays first and player 1 has options, we will see the first column. So in the first column it is given 4 and 7. So in the first column it is given 4 and 7. So out of these two, it seems that out of 4 and 7, 7 gives a better payoff. That is 7 is more than 4. So we will say 7 gives more utility or more payoff to player 1. So the best strategy for player 1 would be when player 2 plays R, player 1 plays R, player 1 plays D. So here player 2 made the first move. So who made the first move? Player 2 made the first move. Given player 2's move, player 1 has decided its strategies. Now we'll see the other way around. That is, say in this case player 1 makes the first move. When player 1 makes the first move, that is player 1 plays say U. So now we will be looking at the column. That is, we will be looking at these two columns and we will be looking at these two levels. That is, we will be looking at the second part of the row. That is, we will compare between 7 and 6, these two terms. So here player 1 makes the first moves and he chooses U, and player 2 makes the second move and player 2 has two options, either L or R. Player 2 chooses 7 because it gives him more utility. So we will compare between the columns here. So we will say for player 2, 7 gives a more utility. 7 gives more utility. So you would say when player 1 play U, player 2 will play L. Now in the other case, when player 1 plays D, so when player 1 plays D, and player 1 plays D, player 2 has two options, either this or this. Now out of these two, it is quite obvious 8 gives more utility than 5. So we would say for player 2 chooses R. So in this Nash equilibrium game, what we have seen, that is when player 2 chooses L, player 1 chooses U. When player 2 chooses R, player 1 chooses D. When player 1 chooses U, player 2 chooses L. When player 1 chooses D, player 2 chooses R. Now among all these strategies, which one is the Nash equilibrium strategy from where no player would like to deviate? We have to figure out. To do this, what we have to do is we need to find out. See, when player 2 played R, player 1, out of these two, player 1 chose 7. When player 1 plays D, player 2 chose R. As you can see, 8 gives more utility. So where, see, find player 1 plays R, that is RD, and here it is DR, and in other cases it is UL and LU. UL and LU. So in this game, as you can see, in two cases, LU, UL and RT, DR, when this opposite kind of thing happens, we say they are Nash equilibrium. So in this game, there are two Nash equilibriums that we have found, this one and this one. So in this game, we have found two Nash equilibrium. So it is a two Nash equilibrium game. So now I'll be repeating what I have done in this case. See, in this case, what I have done is that first we have to, when we are comparing about player 1's first move, then player 2's strategy, we compare the row, the second one, and when we take player 2 to be the first one who plays the game and player 1 makes the second choice, we say that these two are the one which we will compare. So in this case, in this way, we can find the Nash equilibrium. What is Nash equilibrium? A strategy from where no player want to deviate. In this case, we have found it to be two Nash equilibriums. So in today's video, we talked about an example of two Nash equilibrium case. In the subsequent video, we'll solve the other Nash equilibrium possibilities. Say for an example, when in the next video we'll talk about when there is one Nash equilibrium. So thank you for watching this video. If you have any query or doubt regarding this, you can simply WhatsApp me on this number, which is 9836793076. It is 9836793076. But you can also go to our website, which is www.showrupsirsclasses.com. There you will find a lot of other videos like this, and you will also get to see a lot of other links which are needed to crack the various entrance exams. So thank you for watching this video. Have a nice day ahead.